So good afternoon, all of you. Let's continue with the yesterday's session, what we have been doing. Am I clear? Am I audible to you?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, so we will continue with the same thing like we have been stopped at prime number. I'm just discussing with the prime number. So what I will do first is for the yesterday's flow chart, what I have written. Unfortunately, I did not save it, so I have to do it now itself before this class. So I have made that ready. So what I will do is I have kept this screenshot of the flowchart on board. So now what we will do is we will just write down the algorithm. So how I am writing the algorithm, you just look into that and how I am matching that with the flowchart. Okay. So after that, we can discuss if there are any alternatives to what I have done. And after finishing this prime number example, we will then go to this function-oriented programming in Raptor itself. So I will tell you how the functions will work and what are the functions called. So this is one new type of concept that you have to learn. If you have already been acquainted with C and Java, C or Java something, you already know what is a function, but still we need to discuss in this orientation and we need to do the Raptor tool. Right. Let me share my screen. Okay. Right. So I'll just zoom a little bit so that you can look into this. So this is the flowchart yesterday we have been discussing. Like we first give a number, we start with I is equal to 2 and the count is equal to 2, count is equal to 0. And then we basically mention that the I should not cross square root. If the I is less than the square root of the given number, then we are going into the number mod I is equal to 0 and then we are increasing the count. And after increasing the count, whether you are increasing it or not, whether yes or no, it should always increase I. The I will again go to the loop here and again check whether the I is less than square root or not, come into it and check whether true or false and do it. So my assumption here is at least a composite number should be at least divisible by 1. So based on the assumption, if after we come out of the loop, what I am doing is I am doing like this. So if count is greater than or equal to 1, you print composite. Else it should be prime. So I will write parallelly an algorithm that defines this. Okay. Now the first step is naturally step 1, start. Right. So even if most of you knows it, we are doing this because some of them might have not understood about this one. So I want to just demo it again how to write an algorithm for a flowchart, or after writing the algorithm you can also write the flowchart. Anyway, whatever you have done first, the next should be very helpful to the other one that follows it. So the next step is step 2.
Sir,
Yes.
so algorithm and pseudocode are two different things, right?
Yes. So
Okay, sir.
algorithm is a writing description that too in the language we computer science people will understand. Like how I have said the example of chess game, right? It is not completely English. It is something like a command instruction oriented manner. But a flowchart is a pictorial representation for the same thing, how the flow goes. Okay, there is a small difference between them, but basically their aim is to give a blueprint of something that we are doing. For example, you are buying a car. For example, that BMW something, some new model has come. Let the Benz A class anukundam koni. Now, when you're talking about Benz A class, before the car is being manufactured, somebody has already drawn a pictorial representation and a written description about that, which only that mechanical and automobile industry people can understand. So basically these two are same, but one says how the flow goes, the other says the description of how the program works. Now, your doubt.
Actually, I was asking about pseudocode and algorithm.
You know, okay, pseudocode and algorithm both are same. That see, algorithm is a general term. Okay, we can write algorithm in different ways. We can write as English sentence, but a pseudocode is only for computer science, in which we write our own language, some keywords we use, so that we only computer science people will understand. Okay.
Okay, sir.
Yeah. Right. The next number is, so get. So I will underline this basically. If there are some keywords which I am writing, I will do it with some other color so that you people can grasp it. So start and get num. So we don't need whether it is an integer or a float. We only need just get num. So step 3. So here I am using another keyword, assign. Those who have written some English statements. Yesterday I have seen one person in another section writing like, it will now go to that step. He did not even go to that step. He says that all these steps will be repeated. What is this all these steps? If somebody I asked you the address of some person, if you say you go there, after you go there you turn this side and you go, there you find the house. What is that go there and what is this turn this side? What is this? Is it left or right? So it should be very clear that the people who are programming should understand your pseudocode. Okay. As I already said to you in the previous lesson, what is an algorithm and a pseudocode? Algorithm is more general in general terms. Algorithm is written for every process. If you are a king, so in the ancient days, we always listen that the famous Kautilya, who has written Arthashastra, that Chanakya, he has written some algorithm for the king. That means that Chandragupta Maurya to rule, how to rule the nation. And I think he is the person who introduced this panchayati and all in the villages at the time. So he has written that business book. Even still, the MBA people will read that book in some universities, I think, even in foreign universities. So an algorithm can be considered for every profession, even for naval. I already said that for Navy, there is some algorithm on how to navigate from one country to another country. So in computer science, we specially had pseudocode. Why pseudocode? Because we need to clearly mention to what step you are doing, and next is a step that we have to perform. It's a sequence of steps. Sometimes if we want to mention the loops should also be mentioned clearly. At what step you need to go. You simply cannot say all the above steps will be repeated. How many steps will be repeated then? Will it come from the start again? Will it come from the step one? This is very important for you to clearly understand an pseudocode. If, for example, somebody has written a pseudocode and he left the company and you are the new recruitee. So you are sitting in your chair and somebody gave you some algorithm or a pseudocode to you and said, you study this and start writing the code. If that pseudocode is not clear, your first step is to go to the manager or your team leader and ask him, what is this? I am not clear about this. That is why most of the pseudocodes should be very clear. So if you look into the pseudocode, you should be able to do the program immediately. So assign, sorry, I'll go black, all the normal instructions. So I'll do it something like this. So I, 2. So for this in your documentation, in your Word doc, you can type like this. If you press this arrow, and one hyphen, and by the time you press this another hyphen, the double hyphen, immediately it will turn into this symbol. So don't worry for this symbol. Okay, if you press this and the other one, immediately it will turn like this. So there is no need to worry for that symbol. The symbol will be very easy to come. If you are unable to listen what I am saying at the time I am explaining you, that's the problem you always face. The next step will be step 4. Again, I'm assigning something, right? So I'm using the keyword assign, and this time I'm doing some count is assigned with 0. So that means 0 is sent to the memory called count, 2 is sent to the memory called I. And here you can look into this. In step 5, there is a thing called loop, right? You see here there is a thing called loop, right? There is no need to mention this loop here. If you want, you can also mention. Otherwise, you can directly write this one, and every time you can say go to the step 5. Okay. For your thing, I will write loop. For loop, I am indicating like this one, so that you will understand. Loop starts here, and the step 6, you can write check if I is greater than sqrt of num. Okay, then you write another step, step 7. You can write something like a general term if s. Okay, if s, we have a keyword called go to. In C language also we had that keyword go to. Step, we don't know what is the last step, so I'm making it blank. I will leave it for this one, and I will fill it up at the last. Next we go to step 8, and in step 8 we now again check this condition, right? This condition, number mod I is equal to 0. So I will write it like this: check if num mod I is equal to 0. Now you can write something like this. Step 9, if s, every time I'm writing two s's for this. So if it is s, then you have to say like then is a keyword. So I'm putting it into this. So ఈ keywords అన్ని మీకు ఇంట్రడ్యూస్ చేస్తున్నాను because the reason is you can use these keywords for the later algorithms. Only few keywords will be there for our pseudocode. So if yes, tell
Sir,
me.
I have a doubt. In step 6, you are checking if I is greater than square root of the number. So in step 6 only you're deciding whether it is yes or no. So why should I take another step telling if yes, go to step? You could directly
Okay,
tell
but
it steps.
right, 1 minute. If you are deciding whether it is yes or no, then
Yes.
if it is yes, what you will do?
You'll go to the next step. That's whatever step it has to go.
No, I am clearly saying that step should go to the last conditional statement, right? The step should go to last condition statement. So you are asking me to write in the same line?
Yes, sir. The step 6 only, because in the step 6 only it's checking. If it is
So,
yes, it will go
do you
there,
want
and if it
to
is
move this go to step here?
yes, sir. No, I just wanted to ask you whether it's right.
No problem. Asking is not a very bad thing. Just I want to clarify what you want to exactly.
Yes, sir. I want. I think that if yes, go to the step can be written in step 6 also.
Definitely, we can also do that. You can also write it like this. Okay, no problem. You can
Okay,
also say check if I greater than square root of num. You can give a space, go to step. Okay. I
okay,
don't have this one, so I have also made it like this. So
okay,
if there is space, I would have written here itself. That's
yes.
easy for me. I like instead of going to another step. Okay.
Sir, in step 8, you
Okay, sir.
forgot to mention if no. If
Ah,
no.
that's also correct.
Yes.
Yeah. If yeah, I need to move. I think.
Yeah. Sir, I have one more doubt.
Yes. Ask me.
Sir, should the steps be short and clear, or can we combine 2 to 3 steps?
The steps should be short and clear so that people can understand what they have to write it as a program. Okay. So if you combine, that's what we have studied in that lesson algorithms. That if you are making it like a very big sentence or a paragraph, people will try to misunderstand it. Communication is a very important aspect in software engineering. So be clear and give it as a single instruction. Like for example, I said in your class, I don't know. The instruction should be like your military instruction. Have you heard about the marching instructions like buy mode, dyno mode, something? Right? Dynacetastel in NCC, something they will mention these commands. If you say at a time, buy mode, dynacetastel, immediately what they will do? They have to follow all the three instructions. They get confused, and one person will turn right, one person will turn left, one person will walk and dash the other person. You should be very clear. Until they do that, you should not go to the next instruction. Are you understanding what I'm doing? What I'm telling to you? Yes. Hello.
Yes, sir.
Okay. So you need to be very clear. So you can for small steps you can write. For example, what she has asked, you can go to some step like end step. That's okay. But if you cannot combine two things like check if you try to combine all these 4 sentences into one line, that might be very bad aspect. Okay. You need to be very clear. Go to each step separately and instruct them as if they are doing each command individually. And after that command, you say that you go to the next command. Okay. So all these are actually instructions, nothing but commands in our general language. So as somebody said, I will also need to write something like this.
Sir,
How
I
I
have a doubt, sir.
Yes, definitely.
Sir, if we are right now we are mentioning if yes, right, sir?
Yes.
So in case we don't mention if no, will it be automatically an assumption will be considered that else as in like else? If
Here,
not yes, then anything else?
yeah, we
No,
are
in general, yes, sir.
yes, we are clearly writing if S go to some step. Okay. If,
Yes, sir.
if this is not S, naturally it will not execute this statement, right? So
Yes, sir.
it will not go to that step. Instead, it will go to the next instruction.
Yes, sir.
So
So we don't necessarily have to mention
there is
no,
no
right?
need for mentioning this no also. So that is why I have written it. As somebody has asked, I said, okay, I can also include this one. Okay.
Yes, sir.
So one thing you need to remember, some keywords are common in pseudocode, and there is no restriction that you need to include this line or you need to remove this line, but it should be understandable to the person. The final goal is the other person should understand it. That's all. If somebody is reading like this, he said, okay, check square root of a number. If it is just go to that. So if this statement executes, I think it directly goes to the last step, right? If it doesn't execute, if it is not S, naturally it means that the next instruction gets executed, and it naturally means it is no. So there is no need to even mention that it should be no or something. It will directly come to that. It's also a very good question. You can understand that you can write like this immediately. Okay.
Yes, sir.
Okay. Now coming to this, now num percentage num mod I is equal to 0. Then I'm writing if S, then now I can write it something like this. As somebody has asked, I can do like this. Then, so this count is equal to count plus 1 need not be in the another command. You can simply say if S, then count should be assigned to count plus 1. Okay. That's all. And the next thing that you need to do is,
Sir, is assign word not necessary, sir, in step 9?
in
step 9, we should not assign, sir. If yes, then assign count equal to count.
There is no need for you to write assign because we are using then to this. Okay.
Okay, sir.
If you write simply count is equal to count plus 1, nobody knows what it is. So immediately we write some keyword like assign count to, assign count with count plus 1.
Okay.
So that people need to understand. Instead of writing a simple expression, you need to say what is that command, like your military commands, right?
Yes.
Same thing here. I said that if s, then do. You can also mention do here. You can write a do, right? Do count is equal to count plus 1. That's also fine. That also can be written. Okay?
Yes.
Right. If it is S, we are doing count is equal to count plus 1. And we are writing the step. Another step is something like, now you can write assign because I need to add it. Assign I with I plus 1. Okay. And you need to also check. You can also write here. You can also write here. If no, go to step 10. Okay. If no,
Sir?
Yes, tell me.
In step 9, what is written in yellow color, sir?
Do. Something I am
Okay,
saying,
sir.
then do count is equal to count plus 1. Okay.
Yes, sir.
Right.
Now
Now
can
come
I step 9, sir, if no.
Yeah, maybe we can also write it here, but shall I write it in the next step so that it will be not confusing to you?
Sir?
Can you write like that, sir?
Okay. I will write it like this.
Sir?
Yes, tell me.
So we should write the pseudocode according to the program we executed.
No. The thing is that the order is like this. I'm just explaining you how you can write it according to the flowchart, but the order is you need to first write pseudocode. You need to work out first. So you need to work how the program should work. And then you need to write it in a documented form that is called pseudocode. And looking into the pseudocode, you need to prepare the flowchart. And after you prepare the flowchart and you are experiencing that your program is correct, then you need to convert it into program. The program might be anything like Java code or Python or C or C++. Language is not important here. The programming principle is important. You need to think about logic, how it works actually. Right? Did you understand?
Yes, sir.
Your program should be according to your pseudocode and flowchart. Your flowchart and pseudocode should not be according to your program. That's vice versa. That means what we are thinking. Sometimes మనం తెలుగులో మాట్లాడుతున్నప్పుడు చెప్తాం మా అమ్మ నాలాగే ఉంటుంది. That is wrong. నీవు మీ అమ్మలా ఉంటావు. That is correct. The same thing happens here. After pseudocode and flowchart, your program looks like your pseudocode and flowchart. You should not say that my flowchart and pseudocode looks like program. Okay? Did you understand? So I think okay, if possible, I will try to mention here. If no, something. If no, I will use. Excuse me for today because you can also include another step. If no, I am writing here itself because to rub this and do everything, a waste of time into there. So if no, go to what we will say step 10. Okay, step 10. So I'm writing if no, go to step 10. That means it comes here directly. But if it is S, then we do count is equal to count plus 1, and naturally the another step is I plus 1. The same thing I am mentioning. Okay, I'm not executing step 9 if it is no, if it is not satisfying this condition. I directly go to step 2 and increment I is equal to I plus 1. Can anybody tell me what is the next step I need to do? What is the next step?
If I is less than square root of number, then again go to step 6.
That already I have written, right? If check if I is greater than square root number. If the condition is no, naturally this will go to the
Oh,
step.
sorry.
Okay.
If
What?
count greater than or equal to 1.
If no.
So that means for no already we said go to the last step. Anyway, this is the sentence, right? But this is all S actually. That means for S we are going to the last one according to our flow chart. If it is no, we are in the loop. Now what I need to do now?
If I is less than square root of number, then go to the loop.
Oh, first of all, you need to think whether I have given any loop here. Everything is a condition.
Go to step 5.
Yeah,
Yes.
step 5.
Go to
Step 5.
That is correct. So now you write go to step 5. So now you see it works like loop, right? Now you check whether I is greater than square root of number. If it is yes, you directly go to the last step. If it is no, if the I is less than the square root of number, then you enter the loop. That means you come to step 8. Okay, if it is no, naturally. If it is not executing, you come to the next statement and you write check if number is there. And according to this, you are again repeating the loop you see. But somewhere else it might break. If the I value, it repeats until I value is greater than square root. If I value is greater than square root, naturally this statement will get executed, the step 7, and it directly goes to the last step. So we are breaking the loop and going away. Tell me what is the next step I can write? Step 12.
If count greater than or equal to 1.
Yeah.
So that means if you are writing like this, if count greater than or equal to 1, I think we need to write something. Then I can write it here itself, or I can say put, then put, I think it's prime, right? Sorry, composite. Composite. Then in step 13,
else put prime.
Else also is a keyword. That's why we use else.
Put prime.
Yeah. So you can also write something like put prime, like P. And the last one will be step 14, end of the program. Or you can also write stop. Right? Have you understood now? I think somewhere, which is the step I need to place here?
Step 12, sir.
Yes, it is step 12. It is step 12. That means if I is crossing square root, you say go to step 12, it directly goes to step 12, it comes here and checks whether the count is greater than or equal to 1. If it is not, it will put prime and stop. Until this condition, the step 7 executes, the loop repeats on to execute again and again. Because we already wrote go to step 5. Go to step 5 is nothing but it's a loop. So just write down this algorithm in your book if you have it with you and check out how I am doing this. You can also read you can also look into the recording again and again and understand how I am writing this. So better inculcate the idea of writing the pseudocode before you write the flowchart. And after you write the flowchart, if there are any modifications based on the execution, please try to change your pseudocode also, so that your pseudocode and our flowchart should match. And finally, whatever language you are writing to write a program, that should also match with your flowchart and pseudocode that you need to remember. I hope you understood how I am writing. So what are the keywords that you have seen? Start, stop. Stop, I did not write in red. Anyway, you consider start and stop. Get for inputting the values. For output, you say put. for assigning something like I is equal to 0 or count is equal to 0, you say assign keyword. For looping, you can use loop. For going to a particular step, you can use go to. And for if condition, you can use check if. You can also write if it is yes and if it is no. That's what you need to consider. If then is also keyword. I hope you all understood how to write algorithms and pseudocode, algorithm or a pseudocode, whatever it might be. This is the only format for our computer science, right? So first of all,
Yes, sir.
what you will do is first you write an English sentence of algorithm, right? It's general algorithmic term you can write in an English. You convert that into pseudocode so that you will have some idea. Before doing these two things, you need to work out how it actually works. You need to use the rough paper and work out how do the computer understands what we want. Then write it formally as algorithm, then convert it into pseudocode. This is what pseudocode. Algorithm is general English. And after pseudocode, convert it into flowchart. After flowchart is satisfying the output and input, then you convert this flowchart into a program. That language can be any language, whether it is C or C++, Java or Python. This is what the process that we follow. Right. So any alternative to this program, anybody can share the screen and say that it is better.
Sir, it's not alternative, so I can give one more this thing, sir, in that.
Yeah, you can.
So once can you show that same this thing, sir?
My screen?
Yes, sir.
This is the one. Okay.
Yeah, sir. In that, after count equal to count plus 1, you can just have an extra step, sir. I equal to I plus num, sir.
I plus num.
Yeah, why? Because, sir, if you take a number called 10, sir, it is already divisible by 2, no, sir. Then why to check 3, 4, 5, 6, 7? It take time, right?
Why to check 3, 4, 5, 6?
Yeah, sir, because if 10 is already divisible by 2, it's composite, no, sir. So, sir, in order to save time, you can just add 2 plus to a number. 2 plus 10 will become 12. So directly it'll go to this step. So count is greater than or equal to 1.
So you want me to write
Yeah.
here I is equal to I plus num and
Yes.
here I is equal to I plus 1.
No. Here it's not in it's only in yes thing, sir.
Only in S.
Yes,
if
sir.
You only put it in S, and if it is never divisible by anything, it always goes to no, and I is not at all increased, right? For example, you are going for 9, and if I is starting at 2, and 9 is not divisible by 2, it comes to no. If I is not increasing, it always checks in the loop where it is 2, and it goes.
No, sir, not get my point actually. Sir, can I share my screen once?
Yes, you can. You can.
It's showing disabled, sir.
I will enable it. Okay.
Yeah.
You can now.
Yes, sir.
Alert from your disk is almost full.
This one, sir. This extra step added, sir.
Okay.
No, sir. Let me. I'll just run it, sir. Like.
Okay. I understood.
I took it as 10, sir. See, so directly it went to that step without any wasting time. Like 3, 4, 5, 6. Not check it, sir.
Fine. That's fine.
That's the reason I did
it. Good.
I just did it in order to save time, sir. Actually, that's it.
That's what we need to also do it. See,
Yes.
Sometimes if you are increasing the number of lines of code, that's not a problem if you can save the time complexity. Okay, the number of steps you are executing, if you can save it, then definitely it will be far better than what you have increased the number of steps. So I think you have increased one step in this line of code, but still it works because the time complexity is saved.
Yes, sir.
Yes, that's good, Paul.
Yes.
And yesterday I have got one suggestion from one of you. That was a very good one, actually.
That last one, sir. Last one.
No, that's That's not. He sent it in WhatsApp. Can somebody raise that issue that I have been discussing with somebody yesterday from this class itself? Yeah, I will just try
N
to.
by 2, sir.
Amma?
N by 2. We can take I greater than N by 2.
No, no, no. That's not the case. I will just show one algorithm. Wait, 1 minute.
Should I stop screen sharing, sir?
You can stop screen sharing.
Yes.
I think if that person is present, I want to take his permission to show his algorithm. It's not offending, but I want to ask the people to find out the mistake. Initially, that person who has given to me that algorithm, that flow chart, I thought it's very efficient, very efficient than when considered to some other flow chart by the time. After the class, he had shared it to me. But after looking into it, after 3 seconds or 4 seconds, I could recognize for one test case, it's not working. Let us look into that. I'll just go through that one. I'll just show it to you.
Sir, it was me. Can I share my screen?
You can. You have the same flowchart with you?
Sir, I was the one, sir, with the doubt.
That is non-corrected flowchart. I want to show them to understand how the test cases are important.
Yes, sir. One second.
Whatever you shared it to me, you just share that one. Don't share the corrected one. Okay. Are you sharing, Aman? No?
Yes, sir. Yes, sir.
Yeah.
Sir, even I tried doing it.
Yeah. I think now, I think you have changed a little bit, Amma.
So same one, sir. I didn't change it.
No. Keep that I less than 2. I less than 2. Below. Yeah.
Here,
Yes.
sir.
Yes.
Okay.
That I less than 2. Don't run it. Don't run it. Is it I less than 2?
Yes, sir.
Okay. You also kept that equal to. Change that equal to. Just keep I less than 2. That's okay. Right. Done. Okay. Now don't run it. So this looks immediate, efficient flowchart because he's trying to break down at some point of time. People, you can just analyze this one and tell me at what test case it actually fails.
It can show prime number multiple times.
Okay, that's not a case here, and you just
11 multiples.
For example, take 2. Take input as to what will happen. You see, sorry,
yes,
run chain. Take input as 2.
Keep repeating.
So whatever the input is, it will run 10 times, sir. 9 times.
Yeah. Yes.
But however big the number is, it will be calculated easily.
Yes. That's what he has said. So his assumption is even for 100 also, it will only run 10 times. And you take any number you take and say, please come out whether it is really working or not.
121.
So 121 won't.
Yes, that's correct. The reason is,
greater than 10 primes.
Yes, that's what I also thought about immediately after seeing this algorithm. So, for example, if you are giving some 100 or something, also 10, it is divisible by 10. There is no problem. But if you go to 121, this number is only divisible by 11. It is not divisible between 2 and 10. So, when you are writing some algorithms, please be sure that you should be your own critic. Critic in the sense something like politics lo chuste pratipaksha nayakadu. You have to criticize yourself that you are wrong. You bring some test cases towards yourself and test it, and you will definitely know what is it. That's why what happens in the software companies is there will be a group called testing group. So this testing group always never mingle with, they always have a barrier between this developer and the testing group. This testing group, they always recruit a person with negative mind. He always thinks that there is fault with somebody, I am only correct. They will push them into testing. And there is a definition in testing also in software engineering. Once you study software engineering, you will understand. So you should always be negative towards that. Okay. So you should think that something is wrong with this fellow every time. And definitely they will find out more mistakes than anybody else. And I had a story that once Chhatrapati Shivaji is building some forts. And every time he is building some fort, he is calling some person who is with negative mind and he is asking, I will give you some amount of money. If you find out there is a mistake in my fort that somebody can intrude into my bedroom if I am sleeping. So he used to give them the gifts also. The same thing happens in software companies. They give good salary to them if they find more mistakes in somebody's code. So here nobody will find, right? If you're writing some algorithm or a flow chart, please be critical of yourself. Introduce some test cases which will not work if you think that it is not working. But if it still works, then your algorithm is bypassing everything and it is formidable, right? Okay. This is what I want to explain. If people can just guess it, that's fine. I have shown the same thing. I did not name anybody. I have shown the same thing to other section. I think they took around 10 minutes. Now you are fast than that. Good.
Sir, I have done a similar program. Can I show, sir?
Yeah.
First, I have done that.
Emma, can you stop screen sharing? Emma?
Yes, sir. Yes. Yes, sir. Done.
Yeah.
This one, sir. Okay, is it visible, sir?
Yes, yes, visible.
It checks from if you give 10, it checks from 9, 8, 7. When it is when it finds a factor, it stops and checks it is 1 or not. If it is 1, it is prime or not. It is composite, but it is taking only up to 16 digits.
Okay.
Like.
So it is working for maximum all the numbers up to 16 digits.
Yes,
right?
sir, but takes much time. After if you give like this 19-digit number, it takes up to 16 digits, and after that it takes only zeros, sir.
Okay.
Is there any other function like
I
like
think
in
this
say
all,
int or another?
all regarding the memory itself. That means it is only able to take those many number of bits, so that can only accommodate.
Yes, sir. Like see, will this also have any other input type or so?
I don't think it is having such thing, because in C we can go for double so that we can expand the memory for that. But in programming that is available, because program directly controls your memory something. But it's like a flow chart. It doesn't want any number to be included. Okay, if it is working for few test cases, it can do it universally. Any number can be solved. That is why he only gives you maybe 16 digits. I don't know.
Thank you, sir. I'm stopping here.
Yeah.
Sir,
Okay,
once can I share my screen, sir?
Yes, you can.
Sir, actually, I have a doubt, sir. Sir, can't we use cube roots or powers more greater than 2?
I did not understand that. Can you?
Sir, instead of using square root, you can use cube root or other roots, sir.
But I don't think those functions are available to you. But you can write a mathematical expression that might be equal to the cube root. Like some people have written like x star 0.5. It indicates x power half, right? That indicates it's a square root. You can also write like this. What is that cube root? What is the power that you mentioned for a cube root? For a square root, we say x power 0.5. In the sense, in mathematics, we write x power half, right? For a cube root, how you will mention it as a fraction?
Sir, not in Raptor, but in other languages we can use, sir, like Python
In other
or
languages
Java.
also, I don't think that cube root function is provided to you. You need to write it mathematically.
So POW you can use, sir, in
Yes,
Java.
power can be used. That's what I'm saying. Power of x comma 0.5 will give you the square root, right?
Yes, sir.
Yes, like that. What is for cube you mentioned? That's what I'm asking. What is the power for cube root? X power ఎంత మెన్షన్ చేస్తే దాని క్యూబ్ రూట్ అంటున్నాము. That's what I want.
చూస్తాను సార్ ఒక్క నిమిషం.
If you can
keep
know
it going on.
ఏంటమ్మా? Somebody said some answer.
0.33.
Goes on, never ends like that.
I did not understand. Somebody is saying I could not listen to them. Okay,
So potentially 0.33. 0.33 might just.
So what you will do is power POW of x comma 0.3. Have you understood what I said?
Yes, sir.
Yeah. Somebody said they will share the screen.
So can I, sir?
Yes, you can. So this is the last one before we go to some new concept.
Sir, I have written in double loop, sir.
Okay.
Sir, is it okay, sir? I am getting some problem with it, sir.
So is it working for any number? Have you tested it?
Yes, sir.
So I think I need to extend the date of your assignment for your submissions, right?
Yes, sir.
Okay.
So it's going on continuously, sir, but it's not ending, sir. It's going on continuously.
That means your loop is not having a very good condition, so you need to just check it out.
Sir, I extracted this this from JavaScript, sir. That prime number in Java, I extracted it, sir.
Okay.
Some problem, sir.
I think that there is a problem with the condition itself. It is not stopping. You see, once get down. You see, before you come to the end, I think after you are going to an infinite loop actually every time.
Yes, sir.
Yes. So
yes.
There is some change. There should be some change. What have you done? You see, you are testing with n. What is that n?
Sir.
What is that n?
The number we give, sir.
Okay. Okay. So are you increasing I is equal to I plus 1?
Yes, sir. I'm increasing it last.
What is the number that you have given?
15, sir. 15. It's going on, sir.
You keep the speed bar to the last. Let us see. I think you keep that speed bar to the last.
Sir, that output is not connected to the end, I think.
That's what.
Yes.
That's the problem, sir.
Even I faced the same problem earlier.
That output is not connected to the end. Before you come to the end, you should be connecting the output to that.
Yeah. Yes.
Okay, sir.
It's only saying prime and composite. Every time it is measuring whether it is composite or prime. Okay.
Yes, sir.
You just rearrange your flow chart.
Okay, sir.
Yeah.
Thanks.
Sir.
Yes.
I have a doubt. If I put 0 as input, what will I get for the program, whatever you have written? Because 0 is neither a prime nor a composite.
Then you need to write immediately up to 3 something. You can write everything is prime and end it. Okay. You can connect to the last condition and say it is prime. So first, after getting the input for your question, I can suggest you something like this.
Yes.
First, check the input whether it is between 0 to 3 or it is more than 3.
Okay, sir.
So if you can without any measuring, you can directly go with prime and you can print it. If it's more than 3, then you can go down and loop your. Okay.
Yes, sir. Understood.
Now we are ending the conversation for prime number and algorithms.
Sir, once can you explain the float function, sir? Float function.
Float function?
Yeah, float, sir. Yeah. You are telling in the class of float.
flow. I am telling the flow, not float.
Okay. I thought
Flow
it's
of
float.
flow chart. Okay.
Okay.
The process, how it works. Like for example, you are boiling some water. The municipal water flow is there, right? So if it is if they are collecting from Tatipudi Reservoir in
It's
Visakhapatnam,
3:00.
they're processing something, right, for taking out the bacteria, the viruses, the stones, the dirt, everything, and they give us some clean water. Okay, we assume that they give clean water anyway. So while it is coming, you say how the flow is going on. That means the process of filtering the water to its purification form. That's what you are saying, mentioning in the flow chart. The flow chart name itself mentions that it is flow. Okay.
Yes.
Yeah. Float into ఇవన్నీ మన ప్రోగ్రామ్ కి వచ్చినా డిస్కస్ నాట్ డిస్కసింగ్ హియర్. Okay.
Yes.
Yeah.
Thank you, sir.
So now I'm going to the next concept. I'm sharing the board. Now I will ask you people to do few things that are really necessary for our next concept. Now, do you know what is x factorial? How do you calculate x factorial? If x is equal to 5 and 2. How do you calculate x
n
factorial?
factorial by n minus 2.
5 into 4 into 3 into 2
4
into 1.
into 3 into
5 into 5 into 3 into 2.
2 into 1 or 1 into 2 into 3 into 4 into up to 5. Okay? Up to 5. Now, your first task is to write x factorial. Write a flow chart to find out x factorial. All of you should do that.
Now?
Because yes, now. It only connects you to the next concept.
Okay.
It's very easy. You can write a simple loop, a simple condition, and find out. I'm giving you 5 minutes of time to do that.
Sir?
Yes?
Sir, I have a small doubt. Can I share the screen once?
Okay, I will stop sharing it. You can.
So, So I did this thing, sir, flowchart. I completed it, but like one of our classmate did, like he completed the
Yes,
thing
it's-
in the he completed so fast. Like whatever number he took, it will run in 10 steps. Like that, I also want to complete it. So what conditions should I put in, sir? Like, shall I once run and show you?
Yeah, I understand this because we have done the same thing, right? Instead of n, you write square root. It also gets to very less steps, right? So it should be I greater than square root of n, SQRT of n. That will reduce you lot of steps now. For even 100 as a number, if you want to find out whether 100 is a prime or composite, you only go from 2 to 10. That's all, because 10 square is 100.
Okay.
So then in the condition I greater than equal to n, in the condition in the loop, you write down I greater than square root of n. You click on it, double click on it, edit. Yes. Now you write I greater than square root of SQRT of n. You just explore the mathematical functions so that you will have an idea of n, in the sense that okay, close brackets, done. Right? It will reduce a lot of steps to you. And you need to still work out if you want to reduce a little bit, like how Paul has said another condition like I is equal to I plus none something. To explore those things. Paul, can you share your flowchart screenshot in the WhatsApp so that people will also look into that and try to improve it more?
Yes, sir. Yes, sir. Sure, sir.
Yeah. Okay, sir. Yeah. Thank you, sir. I'll try it out once again.
Fine. So I'm giving you 5 minutes of time. Please finish up with that. Already 1 minute is over. Okay, last 3 minutes.
Sir.
So did anybody finished it?
1 minute, sir.
So I will give you 1 minute, okay? Now it's 3:08. I will get back to you again at 3:09.
Yes, sir.
Sir, for multiplication, we should take the key X, sir.
For multiplication?
Which key we should use, sir?
Asterisk.
X.
Asterisk. Above 8, there is some symbol like asterisk, star symbol.
Okay, okay.
Multiplication.
So today, after extending your time for the previous assignment, I am creating new assignment in which you need to submit today's tasks. Can anybody share the screen if possible? If you have finished, stop.
Yes, sir, but I'm not getting the right one.
Anybody wants to share the screen?
Alert from Google Chrome. American Express webinar on scalable solutions is live. Alert
Shall
from
I share mine, sir?
Yeah, you can. You can. Okay. Right. So what exactly it is doing is you can put the speedometer to less so that each step we can observe. Yeah. Yeah. Okay. Right. Now you can run the program. So it is asking for n value. Put 5. Okay. All of you look onto the screen. So it is looping, and you can observe how it is going on, multiplying 5 with the next numbers. It is multiplying 5 with 1, 2, 3, 4. Your answer is wrong, I think, right?
Sir, it should be 120, right?
Yes, it should be 120. That's what I'm saying. 5 into 4, 20. 20 into 3,
23 is 60. 60 to the 120.
into 2, 120. 120 into 1, 120. Okay, I think there is some wrong in your thing. You can stop sharing it.
Alert from
Thank you.
Your disk is almost full.
Okay. Anybody else who is
Sir,
yeah?
once can I share, sir?
You can.
Yes. Sir, can I see, sir?
Yeah.
Yes. Now I'm running it.
You 5. Oh.
Factorial.
You are getting 1 by?
Yes, sir.
It should be 120, right?
Yes, sir.
Okay. Stop sharing it. Fine. You need to correct your flow chart.
So can
Okay,
I?
sir.
Yes, you can. Who is sharing now?
Dedipya, sir.
Okay, Sridipya, you can. Sirish, thank you, and you need to correct your flow chart.
Okay, sir.
Yeah, now you run the program. You run the flow chart. Let us see.
It showed 24, sir.
So it is also wrong, I think.
Yeah, 120.
It should be 120
No,
anyway.
it's correct.
Yeah.
Correct only, sir. 4
4
factorial.
factorial is 24.
You give 4 as
Yes,
factor.
sir,
Yo,
it is 4.
4 is correct, sir.
Then 4 is correct. 4 is correct. I thought you have given 5. Right.
One skip 5.
No, it will work.
5? Okay, yeah.
It will work. If it is working for one n, it will work for all.
Yes, sir.
Now, Dedipya, can you slow down the process completely to the last? Can you put the speedometer to the first? Drag the not that one. Not that one. That is zoom.
Beside.
That that bar is there, right? That bar. Besides that 100%, there is a bar, right?
Okay, yeah.
Put the speedometer to the first. Yeah, people should understand how it works, right? You go top. You go to the top. Yes. Okay. Right. So now it is asking for n to be entered. She's entering some 5. Enter 5. Okay. So you see how the loop is going on. Each time the factorial is initialized to 1, so factorial 1 into 2, like that it is going on. Okay, right. Okay, Dedipya, thank you. I will just share my screen to explain it, what will happen inside that, and we'll go through that. So, what these people are doing is, initially they are taking like, I will share the screen, right? Forgot to share it. So, you start with n is equal to 5, and what it is showing is, you need to do something like, maybe there are two ways that you can do. For example, if factorial is 1 and you need to increment 1 and you need to do that. For example, I write factorial is equal to 1. The next thing that you do is you start with I is equal to 1 and you do something like factorial is equal to factorial into I. And this I will be incremented, I is equal to I plus 1 in such a way that I should not be greater than n. That means what is n here? N is equal to 5. If I is coming to 6, the loop will be broken down. If I is not crossing 6, crossing 5 and it is equal to 5, then you can go on into the loop and increment I value every time. So now I will explain you how it works. Whatever DDPA has given, I hope this is what, and I'm explaining it. So initially I said f is equal to 1 and n is equal to 5. Now I will check the loop. I will also say I is equal to 1. These are the initializations. Now I will check if I greater than n, go to end. Otherwise, you go inside and do something like f is equal to f into I. So initially f is 1 and I is 1. So f into f, so f value will become, now I am changing the values you see. Now it is 1, right? After this one, the next step I will do is I is equal to I plus 1. So I am increasing I. This is I. So now my I will become 2. Okay. So again, this will come back to the loop and check here. I is greater than n or not? No, n is still 5. Okay, n is always 5 here. Now it comes inside. If it is no, then f is equal to f into I. What is previous f? F is already 1. So the calculation that happens is 1 into what is I now? 2. So what will be the recent f? F is equal to 2. Now I'm changing f to 2. Right? Now after this, it will come down. I is equal to I plus 1. So it increments I to 3, right? So again, it will go to the loop and checks whether I is greater than n or not. So I is 3 and n is 5. Yes, it is false. So it comes here. It executes this statement. What is already f that is written? So f is equal to 2 into what is I? 3, right? Is equal to 5, right? The recent f will be 5. So now change f's value. So this is how you can write down f value. I'm sorry, 6. Yeah, f value will be 6, right? Next, it will come to I is equal to I plus 1. What will be the reason next I? It will be 4. It will be 4. Now it again loops back. So n is greater than, I is greater than n. What is I value? 4 and n is 5. Yes, it is no. So you come inside. You again write down f is equal to what is the recent f? 6 into what is I? 4, that is equal to 24. I think now I need to change f value to 24. Right? So after changing it to 24, the next step will be I is equal to I plus 1. So I will become this time 5. So I will change it to 5. Right? And now I am coming back. I is equal to n, but I is not greater than n because I is 5 and n is 5. So it is no. You come inside, again do f is equal to f into I. So what is recent f? 24 into what is recent I? 5. It will give you 120. So your f value will become 120. And next you will increment I is equal to I plus 1. So the next value will become 6. And after checking here 6 is greater than 5, you say yes, it is okay, and come to end and finally print your f value what is there. That's what Dedipya has done, right Dedipya?
Yes, sir. Yeah.
Yes, okay. So that is how your factorial is coming on. Now I had another question for you. Now do this one. The thing is that the x should be given some value. What value is the input? And n should be given some value, and compute this formula once. So in computer science, you can estimate this formula as something like you can also use x star star n, which is the power, okay, slash your n factorial. Now whatever you have done, combine these two things. Now for the next concept, you should understand the difficulty of writing these statements. That's why I'm making you do one by one. If I say the next concept immediately, you will not understand the importance of that concept. So for power, I think you can also use, you can explore the math functions in Raptor. Maybe POW is the function for power. You can write x comma n. It indicates x power n. And there is also another way like Python. Raptor is also accepting 2 stars. If 1 star is there, it's a multiplication. X into n. This means x into n. But it is x power n if you mention 2 stars. You can mention the formula like this: x star star n slash n factorial. Okay. Now I think you need to compute this one now. The next task is this. I am giving you 10 minutes of time for this. So explore various symbols in Raptor that can be useful to you for this and do it. So 3 minutes is over and another 7 minutes is left.
Sir?
Yes.
Sir, at the last, there is a kind of different symbol in the, like it's a P which is reversed kind of thing. How to get
Ah,
that?
that is different. That is different. That's not required. That is the problem with the software, the Raptor that is coming. Okay.
Sir, we should find x power n divided by n factorial, right, sir?
Yes. Yes.
Okay. Okay.
So Agarwal, that is not a symbol actually. That is saying that it's the end of the line. That might not appear in all the softwares. Okay.
Okay, sir.
That's not a fault actually. If it is coming, it is a fault actually. So for me, I'm running in Wine, so there is a problem with that. Anybody is using Mac here? Mac or Linux environment and running through Wine?
Yeah, sir, I used to use, now I changed it to Windows, sir, that day. Yeah,
Okay. Fine. I thought initially to go for Windows. I had another Windows laptop here, but I thought no, again taking it to another computer is difficult for me. So I'm working with this only.
I changed it because of Raptor only, sir, because it's tracking for every file.
Yes, yes.
The reason.
So after Raptor, I think any computer you can enjoy for Python.
Yes, sir. So it's completed, sir. Completed. Your voice is breaking, sir.
Already?
Yes, sir.
Okay, you can share the screen x power n by n factorial. Even the time is, yeah, maybe my internet is
Hello.
Hello?
Yes.
Paul, you can share
Alert
it.
from your disk is almost full.
Can you see my screen, sir?
Yes, yes.
I use DDP ID as at last. I just ended this thing, sir. I added this thing. That's it.
Good.
Sir, even my program is almost the same here.
Yeah, that's fine.
Anything it takes, sir. You take.
To understand what Dedipia has shown and what I have explained on the board, it will Maki, ఎందుకే reverse music to.
Yes, sir. That's it, sir. It's coming correct.
That's
I take
good.
the calculator actually. Yeah.
So if you can understand what Dedipia has given in the chart and what Vivian, Paul and Dedipia, can you share your previous programs along with this, if possible, in the WhatsApp?
I think they attached the experiment to this previous program, right, sir?
That's all.
I just use DDP. I just added two terms. One is input as X and
we have to attach two things, like I guess.
The last thing Paul has to do is just to put that M, because he has.
I'm not able to do that.
Yeah, sir. That's it, sir.
Right. So I think most of you understand how to do that. If Paul has shown you some easy flowchart that earlier he used the Dedipius idea. I cannot say Dedipius idea. It's not patented, but some of you might got the same idea also. But we are just mentioning it like this to nail idea, which we have discussed, and along that is called M and is printing value. That's all. The remaining thing that he has to do is to output that one.
Yes.
Now, Paul, can you stop sharing it?
Yes, sir.
Okay.
So how to do that x power n? How can we get that?
That's what I said. X star star n will give you x power n.
Okay.
You can just do shift plus 8 twice.
Shift plus 8.
Yeah.
Okay. Thank you, sir.
Okay. So if you say shift plus 8, people will also press plus also.
No, sir, no.
You press shift and 8 button. Okay. Because this is the problem with first year. When my instructor said to me for the first time, I even did not have a computer at my home in the lab. She said something like, you enter shift plus some number. I was pressing shift plus at that number. So I know the difficulty for the first years. Okay.
Yes.
That's why I'm saying it. Okay. Now I had something new for you to do the same thing after you do this idea. Now you have done this, right? If and how to do it, the simple thing that people have done it.
Your voice is breaking, sir.
You got this.
Your voice is breaking.
Voice is breaking, sir.
Factorial as the one. The other thing that they have done. Yeah. Now is it okay? Yeah. And now is it okay? Maybe it's the problem with my neck.
Yes, sir.
Now it's okay, sir.
Hello?
Yes,
sir. Yes, sir. We can hear you.
Hello?
Yes, sir. You're audible.
Yes, sir. You're audible, sir.
Hello? Am I audible?
Yes, sir.
Yes, sir.
Okay. Okay, right. So after with the previous so after pre-20 for the factorial, the remaining thing Paul has done is just x star star, which is above 8 key, and he has said n divided by that f, whatever value that he is coming, but that it is coming. So he has said that answer is equal to this one. This is what he has done and finally printed the answer. Simple thing. The previous algorithm plus this step, x power n by f. That's all. Now I had another task for you. That is, I might give you x value or something, you input it, and I also give something like, I don't ask you what is n value, I am giving the n value. X power 1 by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial. Please compute this. Can anybody say, is it very easy to compute?
So do we need to take
Awesome.
3 numbers and then add it on like that?
3 numbers and?
Like for x by 1 factorial, one variable, we'll assign one variable, and for x square by 2 factorial, assign another variable. And then for x cube by 3 factorial, we'll assign another variable. Then print a plus b plus c or something like that.
You try out how easy it might be. For one thing you have done very easily, but now I am expand this series to x power n. Now I think you need to write a flowchart in such a way that this series should
So your voice is breaking.
Voice is breaking, sir.
Internet. I think you understood that this is the task. Can you do it easily without any clumsiness in the program?
We can use loops, sir.
Yes, you can use loops. I think it creates a lot of clumsiness, right?
Yes, sir.
Yes.
To write down these many things, I think x power 1 by 1 factorial, x power 2 by 2 factorial. Of course, you can use loops, but still there is some clumsiness. But I want to do something that is very great and very easy. It removes clumsiness and also helps me some reusable aspect. So software engineering, something called reusability. I will now show you how you can reuse something. Okay, now what I will do is, people.
So again, your voice is not audible.
Yes.
Still it is not clear, not audible now?
Now we can hear you, sir.
Okay, right. I think I'm using Airtel. Airtel is very good for sometimes. Sometimes it creates a lot of bad things regarding the net speed.
Yes.
I'm also using fiber net. It is always bad for me. That's why Airtel.
Again,
Okay.
sir, your voice broke, sir.
Again. Right. I think even in recording also the breaking voice will be there like that. I think it will not catch it clearly.
Yes, sir.
Okay. Now I think I want somebody to do the program now. Somebody to do the program or whatever you thought like using loops. I want to discuss showing the program how easy I can make using another concept. Somebody in the sense all of you should do that. Now do this series like x power 1 by 1 factorial plus x power 2 by 2 factorial plus x power 3 by 3 factorial. Whatever n value I give, up to that you need to compute and give me the solution. So I give you something like for modifying it, you take another 10 minutes of time. If today's class is over, I will continue this discussion tomorrow because I want a clear one period for explaining the other concept.
So now what you are asking us to do?
Yeah, you need to compute this series.
That x by 1 factorial plus
n value. I give you n value. Maybe n value is 10. You need to compute up to x power 1 by 1 factorial to x power 10 by 10 factorial.
Okay.
Your program should do that.
Okay.
So first you have computed 1 factorial, right? Next you have computed x power 1 by 1 factorial. Now I am asking you to compute this series.
Okay. Sir, but that series is actually known as e power x series, sir. Sorry, e power n.
Yeah, I don't know much mathematics and there you are fresh mind, so you know that. But I only know the series equation. That's why I'm writing this. I think, is it Agarwal who has said this?
Yes, sir.
Yeah, thank you, Agarwal. I forget this series actually, but I only remember this series. I don't know the name of that. This is the best example for the next concept I'm going. That's why you need to feel the difficulty of writing this type of program. So today I will open another assignment for this. I think most of you should understand. This time there is no need of algorithm. You just write down the flowchart for factorial and x power n by n factorial flowchart and this series flowchart. Whatever Agarwal has said, like e power x series something, you do it. So all these 3 flowcharts should be submitted.
Sir, once can you repeat, sir, please?
3 flowcharts, sir.
Yes, first flowchart is factorial flowchart. Next flowchart is x power n by n factorial flowchart that just Paul has shown. The last flowchart will be the series flowchart.
Series. Okay. So last date.
Sir, this series up to third factorial only.
Any number, you give any number that should compute.
Sir, do we need to write pseudocodes also, sir, for that?
Not
for this assignment, there is no need of pseudocode because I want to just test your, patience in writing this code.
Yes. Sir. Okay. Sir.
Last date.
Last date tomorrow evening.
Okay.
Tomorrow evening.
Because there is no pseudocode, it doesn't take much time to upload.
Okay.
So I will open the assignment after the class and I will also extend for the previous assignment. You also submit that.
We should even submit the prime numbers one.
Yeah, that prime number, I think earlier you have already submitted. I am extending it if somebody who did not submit. So that for that you need to write your pseudocode like how I have explained earlier, right? And then the flowchart. And for this assignment, there is no need of any pseudocode, only 3 flowcharts.
Sir?
Yes, Sirish.
All we have to submit by tomorrow evening or prime numbers now only we have to submit, sir?
Tomorrow evening. I'm giving for everything tomorrow. Okay.
Okay, sir. For prime number, for prime number, we have to even submit pseudocode, sir.
Yes, pseudocode. First pseudocode, the next page will be flowchart.
Okay, sir.
Okay. Agarwal, you are asking something?
Sir, we should make a PDF of a screenshots and share it.
Yes. Because that will be good for me to correct also. If there are any mistakes, I can correct it and I can give a feedback in the WhatsApp. I can send that one if there are not mistakes.
Sir, for this question, I have a doubt, sir.
Yes.
Sir, there's this formula e to the power x is equal to 1 plus x squared by 2 factorial. It keeps on going, sir.
Oh, okay.
So can we use e as 1 minute, sir. I'll share my screen for 1 second.
Let me stop sharing my screen. Okay. You can.
Alert from your disk is almost full.
Hemant, are you sharing the screen? Hemant, are you there? Okay, anyway, whatever might be the series, your task is to write down that series like x power 1 by 1 factorial plus x power 2 by 2 factorial to x power n by n factorial. Because I want to test your patience of writing this algorithm and the flow chart, maybe flow chart, and I want to see how well you can write it and how well you are frustrated with that and how well you think that it is very easy for me to do. Then if I explain the other concept, that's why I'm not asking you to write the pseudo code, because this is only to test your patience. My belief is only one thing. Like, if you don't see, sometimes we don't understand what is the use of something until unless we face a problem and find out its use. One day I was just going through a temple. I was just climbing the stairs, and for each stair they have just sticked something like a radium sticker which is yellow color on the edge of step. I thought why it is required. I'm just seeing it with the lighting and everything. I thought it is all for the gesture of something, that there are steps. Something I thought this is all because of some passion or something. And one day I was just climbing down our Geetam stairs in that ICT Bhavan, the Chhatrapati Shivaji Chandrahas Bhavan. I suddenly started to slip the steps because I did not recognize that there are steps actually. I thought it is a floor. They are not at all visible for me for the first time when I am climbing down. Then I realized that what is the importance of that radium sticker at the edge of that step. So I want you to face the problem first. Then if I say something, then you will find the usefulness of that particular concept.
Sir, are you speaking anything, sir? It's new. We are not audible, sir.
Is it not audible? Whatever I have spoke now.
Steps 1 was audible, that you understood the importance of radium.
Okay. Anything that is audible, that's fine.
Yes.
So I'm telling, like, if you face the problem, then you understand what is the next concept's importance. That's what I'm speaking about.
Hello. Hello.
Yes. Somebody wants to speak now? So am I audible now? I have just extended the date. You can go through that one.
Okay, sir.
Sir.
Okay, sir.
So created the second assignment also. After you have done it, you just upload it. I want to see how many of you have done this. So tomorrow we will discuss the next concept based on this example. Maximum.
Sir, we have to make all three flowcharts as a PDF and then submit as we did earlier.
Yes, that's correct. You can submit each flowchart in one page and you can submit it.
Sir, we have to make it PDF and we should submit, sir.
Yes.
Sir, can we resubmit the previous assignment, sir?
I think maybe you can. I don't know what buttons or submit buttons have been given to you. Please explore it and tell to me whether you can resubmit it or not, because I have extended the date up to tomorrow, right? So maybe
Yes,
try out to resubmit. Okay?
But when it is on, I couldn't submit again and again, sir. And I had a small edit, so I want to submit again, but I couldn't the last time.
Okay.
So I'm asking.
Maybe I'll look into the settings if possible. Not many settings have been given. If in future, if it really doesn't work, anyway, after coming to programming, there is no need of this relearn assignment. The assignment will be in the GitHub, so no problem for that.
Okay.
For resubmission and all, let us see the settings. If the settings are not good, then we can also migrate to another platform where we can submit the assignments.
Yes,
Sir, when should we submit prime and prime composite number, these things, sir?
Both tomorrow.
Okay, both of the assignments tomorrow. Okay.
We have given up to night 12 o'clock, but anyway, by tomorrow evening, that means if possible, I need to see how many of you have submitted by tomorrow's class.
Sir, this prime composite number, can we send it by tomorrow night?
Yes, you can. But this flowchart for today, you send it.
Yes, sir. I'll consider this flowchart, sir, today.
So tomorrow morning,
you can make changes.
Check how many of
First
you
one.
have done it. So.
Sir?
Yes.
Are there any marks for this, sir?
I'm giving marks like for today's assignment, it will be 20 marks.
Okay.
Hmm.
Means for three flowcharts, 20 marks, sir.
Yes, yes, yes.
Okay.
So for three flowcharts which you gave today, should we write the pseudocode also for them?
No need, no need. Just flowchart is enough.
Okay, sir.
If you want for practice, you can write. No problem.
Sir, tomorrow evening up to what time, sir?
It will be up to night 11:59, I hope, because they have not given us the timing. Every time when we set the date, it will be up to 11:59. But intentionally, I am giving like this assignment should be submitted by tomorrow 9, so that I want to check how many of you have submitted. Because it's easy, you can sit for one half an hour and you can do this immediately. Okay, so the prime you can submit any time in the day. So I think if nobody has any doubt, let us leave for today. Bye bye, all of you.
Sir, the third one should be only x power 1 divided by 1 factorial plus x power 2 divided by 2 factorial plus x power 3 divided by 3 factorial. That's it, no, sir?
If you give what is n value, that's fine.
Only 3, no, sir?
I'm not giving 3 as restriction. You give the
It's
n
4
value
o'clock.
so that the series will start with 1 and it should end with n.
Okay, okay.
Yeah.
Till infinity, you can say.
Yeah, till infinity.
Okay, okay.
So, are you unable to see the assignment in GLearn?
Yes, sir.
I'm able to see this.
Alert
I did
from
not add for the other
your
section.
disk is almost full.
I only added for one section, that is IoT something, I think. I will add for DS also, and I will I even need to spend the date for DS also. I forget to do that.
Sir,
Yes.
We have to take screenshots and make it PDF, no, sir?
Yes, yes.
Thank you, sir.
Okay, for DS also, I'm giving the assignment. You can just check out this one and say whether it is. Okay. Yes, now I have added. Just check out. Money Venkat. Can you check out that one?
Yes, sir. It is visible.
Okay, right. Now, fine. We will stop the session. Bye bye, all of you.
1 minute. So my internet connection, it was bad.
Okay.
So the question I wanted to ask is, there is this mathematical expression, sir, e to the power x. It is equal to x to the power 0 by 1 factorial plus x to the power 1 by 1 factorial. It keeps on going, sir. So instead of doing all the looping, we can directly write, we know the value of e as 2.718. So we can directly do we can assign a variable x as 2.718.
Okay.
And we can do e star star and n.
Yeah,
And
yeah.
in looping, we can keep n is equal to n plus 1. So
Okay.
can we use that method, or should we do it the complicated way?
I want you to do it only the complicated way.
Okay, so fine.
Yeah. Because I want to show you one concept. That's why I want to make you do in complicated way.
Okay, sir.
Do the same way how I am giving the equation. Okay, x power 1 by 1 factorial plus x squared by 2 factorial, like that.
So total there are two assignments, no, sir? One
Yes.
is the factorial and the other one is this.
Yes.
Okay, sir. Thank you.
Okay then. Bye bye.